Okay, let's dive into this explainer. Today, we are taking a seriously fascinating, mind bending journey to question the very fabric of our reality. I mean, most of us just go through our day assuming that the ground beneath our feet, the ticking of the clock on the wall, and the space we occupy are all fixed, undeniable truths. But what if they aren't? What if everything you think you know about space and time is fundamentally just an illusion? To really wrap our heads around this, let's start with a simple thought experiment. Picture this. You're just relaxing on a park bench, and a blind man sits down next to you. He asks you to describe the beautiful weather. So you say, well, it's evening, and the sky is this warm, brilliant orange. But he stops you right there. He asks, what does orange mean? You realize he's been blind from birth. To him, orange is just a fruit. You try to explain that it's a warm color, like the warmth of a fire. But he replies, the fruit isn't warm, so what are you talking about? And when you finally ask him what image forms in his head when he tries to picture it, he says, nothing. Not a black screen, just literally nothing. I want you to genuinely think about that for a second. By simply lacking one sensory organ, the entire universe is completely different for this man. His reality is fundamentally altered. It proves that reality is entirely subjective, based on how we perceive it. So if losing just one sense changes the universe that drastically, how can we be so absolutely sure that the way we perceive space and time is the ultimate truth? And that brings us to a grand cosmic mystery, an unsettled debate that has literally raged for thousands of years. Think of these as our two main suspects. On one side, we have absolutism. This is the philosophy that space and time are totally fixed, real entities that are exactly the same for everyone. On the flip side, we have relationalism. This view argues that space and time actually differ from person to person, totally dependent on the unique observer. To put this into perspective, think about this striking statistic. 1 in 12 people experience some form of colorblindness. And this brilliantly illustrates the relationist viewpoint. An object you definitively see as blue might look completely yellow to someone else. They are seeing a totally different reality than you are. Since colors are spatial entities born from light, relationalism suggests that ultimate concepts, like space and time, are just as unique to the individual observer. Section 1, the Newton-Leibniz debate. Let's rewind a bit and do a little historical investigation to see how the greatest minds in history battled over this exact mystery. If we trace this debate through history, you can really see its sheer chronological momentum. We have been wrestling with this for centuries, from Descartes in the 16th century all the way up to the quantum Nobel Prize winners of 2022. It is a mystery that science just simply refuses to let go of. Back in the 16th century, the philosopher René Descartes pushed the absolutist view. He plotted reality on a 3D graph, basically mapping out nature's objects without disrupting the universe's rules. Isaac Newton later took Descartes' coordinates and used them to derive his famous laws of motion. Newton really cemented the idea that space is a fixed stage, and time is a clock that moves forward at a fixed, unstoppable speed for absolutely everyone. Time waits for no one, right? That is textbook absolutism. But then, enter Gottfried Leibniz. This guy was a brilliant German polymath and the true inventor of calculus, even though Newton famously tried to steal the credit. Leibniz fired back at Newton with a fiercely relationalist theory. He argued that space isn't a fixed grid at all. Instead, he proposed that space only exists as a property of particles, which he called monads. These particles constantly attract and repel each other, and it's their interactions that create the illusion of space. Without the particles, space wouldn't exist at all. Section 2, Einstein enters the chat. Fast forwarding to the 20th century, a familiar face is about to turn this entire debate completely on its head. Albert Einstein completely shattered that fixed universe model. Now, what's really interesting about this slide is how, with his theory of relativity, Einstein proved that space and time are actually a single interconnected entity called space-time. And incredibly, space-time warps and slows down depending on how fast the observer is moving. Space and time are completely relative to the observer. This was, obviously, a massive victory for relationalism. Actually, scratch that. It wasn't a total victory. Einstein kinda accidentally created a paradox. While relativity proved time and space change based on the observer, Einstein also used the concept of gravitational fields. And just like electromagnetic waves, gravitational fields technically require a medium, meaning space, to exist. So Einstein ended up landing dead center between the two philosophies, leaving our grand mystery totally unsolved. Section 3. Emergence Theory Explained. Recently, a group of scientists in Los Angeles introduced a mind-bending twist to our mystery. They suggested that space and time are fundamentally born from our own minds, and that the past and future actually exist simultaneously. According to emergence theory, our reality works a bit like a shadow. Imagine a perfectly symmetrical crystal in 8 dimensions. When you shine a light on it, it casts an asymmetrical 3-dimensional shadow, which we call a quasi-crystal. Our entire 3D universe is theorized to simply be the projection, the shadow, of this 8-dimensional crystal. Let's zoom in on that a bit. If you zoom all the way in on this 3D projection, you'd find the fundamental building blocks of our universe aren't what we thought. They are tiny 3D shapes called tetrahedrons. And when I say tiny, I mean their side length is the Planck length. That is 10 to the power of 16 times smaller than the standard particles physics usually talks about. The arrangement of these unfathomably small tetrahedrons builds our entire universe. Section 4. The Quantum Observer. Which brings us to the most critical question. What actually decides how these tiny tetrahedrons arrange themselves into the world we see? Well, brace yourself, because the answer might be our own consciousness. Look at reality as nothing more than pure information. Information only gains meaning when we actively compare patterns. For instance, you only recognize a specific shape by subconsciously comparing it to the lines that are missing. This active comparison requires a choice, and choice requires consciousness. Reality isn't just sitting out there passively. It is actively born from the mind analyzing this information. Now, I know that sounds like science fiction, but it's actually backed up by the 2022 Nobel Prize-winning science of quantum mechanics. Specifically, it relates to a bizarre phenomenon called quantum entanglement, where 2 particles are generated from a single source and remain deeply intrinsically linked. Before anyone looks at these particles, they exist in a state called superposition. This basically means their properties, like their spin, their position, their momentum, remain entirely undecided. Think about that for a second. Reality literally has not made up its mind yet. The physical traits of the universe are just hanging in limbo. So, the crucial point is this. It's only when a conscious observer actively looks at or measures the particles that they collapse into a fixed, decided state. This is known as the observer effect. And because every single one of us has unique, highly complicated neural circuits in our brains, we all process this collapse differently. We are effectively creating our own completely unique version of reality. Space and time are entirely relational to you. Emergence theory is incredibly exciting because it has the potential to finally bridge Einstein's relativity and quantum mechanics. And the science is advancing at lightning speed. Scientists have already successfully simulated a completely functioning helium atom. In the near future, they might be able to simulate complex molecules, objects, and eventually, perhaps, even human brains. If consciousness creates reality, and if we are already learning how to simulate the very atoms that make up our universe, it leaves us staring down a pretty haunting conclusion. If reality as we know it is just a projection decoded by the observer, we really have to ask ourselves, are we actually living in a simulated world? It's a massive, provocative question, and one I highly encourage you to keep exploring. Thanks for joining me on this explainer. Stay curious and keep questioning the reality around you.